Hi, I'm Professor Kandaga, and I will present my paper titled A Lesson Study to Foster Prospective Teachers' Disposition in STEM Education. Let's start with introductions. Experience in teaching is as valuable as learning the theories. Fostering their own knowledge and disposition is necessary for their role as teacher in the future. Prospective teachers not only need to deepen the content and pedagogy, but they also need to know the tools to convey disposition and attitudes to foster. There are two important quotes in this study. First come from Lillian Katz. She argued that disposition falls inside learning, and any educational approach that undermines disposition is miseducation. Of course, we should also foster disposition in STEM learning. Furthermore, I suppose STEM education could deal better in fostering students' dispositions, since technology is naturally always tempting for today's people. Nevertheless, Boyce and his colleagues argue that the use of technology in learning must be done appropriately. Otherwise, the misuse of technology in learning is instead making a negative impact on the learning process. In many conditions, technology can turn complexity into a lot easier and more enjoyable. So, how could we misuse the technology in learning? Well, for example, in elementary school, the use of calculator for simple calculation like 7 multiplies 12 will only negate the thinking process, which is more useful for the student's future knowledge. However, it doesn't mean that the calculator doesn't help mathematics learning at all. In various calculation and more complex problems, like numerical methods, the use of calculators greatly helps both thinking and learning process. Hence, this study is trying to design the learning to foster prospective teacher mathematical dispositions with the proper technology integrations. This research, conducted in lesson study format, with purpose to design a proper integration between technology and the classroom learning. Students divided into 2 parallel classes. This will enable minimum cycle of lesson study. The first stage of lesson study is planning the chapter design. The design reviewed by both lesson study and the content expert. Second stage of lesson study is to implement the chapter design in the classroom. Several observers assigned for each group of students. The teaching session is also written down and recorded in video by a specific person. This will give a more detailed description of events in learning. In the reflecting sessions, every observer gives feedbacks to revise the chapter design regarding mathematical disposition indicators to achieve, and then repeat the lesson study to the other parallel class. The last lesson plan and chapter design expected to be an ideal outcome beside the students' mathematical dispositions. Since the learning is the first goals meeting, it starts with an introduction of learning of the linear programming. This is intended so that the students explore and try to solve these problems with the knowledge they have. This was also an opportunity for the instructors to recall various knowledge about linear programming. This recurring process is important as a warm-up, so the students can be directly connected to the learning. As can be seen in this figure, some of the keywords are repeated, such as vertex, maximize, minimize, and profit. This keyword is repeated continuously from the beginning until the end of the learning. The understanding is deepened, and certainly all students have an equal understanding. This understanding and exploration of vertices and profits continues to be deepened until all students understand that profits can occur in any known vertex. Then, in this table, this is a snapshot of the conversation between the instructor and one of the students. The instructors asking about the contextual problems. He asked, what does the talents have? And the response is wool, cotton, and silk. What the talents wants, and the student responds, profit from selling clothes he makes. So the students has already know what the tailors wants, and the instructor deepened the questions. Why the tailor didn't just make 100 model of A clothes? Then the student's response, I think he doesn't have the material to make the clothes that much. From this conversation, we can see that the students has already known about the problem. After the students knowing the problem, then we continue to introduce the software, the technology. It is the POM-QM software. In this phase, the chapter design underwent a revision from experts. In the first cycle design chapter design, the instructor gives a brief explanation about POM-QM and its use. However, after the reflection stage, the instructors leave the students to explore and try POM-QM themselves. Most of the POM-QM menus and functions are available to see. Those make it easier for students to do trial and error. As Mela Silver says, experiential learning is more meaningful and less linear for students' knowledge. We can see the video. We can see that the student exploring their own POM-QM by learning the models, and they do the trial and error. They discuss each other. And they start to input the models from the contextual problem given. Okay, let's just continue to our next slide, the results. There are several results in our study. From our results, grouping has proven effectively encouraging the discussions diligent students take control of the discussions. They share their knowledge and their finding about the POM/QM software. The technology integration, students show cheerfully and satisfied for every idea confirmed as true, and they pay attention carefully when explained that their idea was invalid. This technology integration shows that the students has a very good interest in the topics. The disposition, all students, even the person who is not usually interested, trying to understand and participate in solving the problems because they are equipped with perfect tools like POM/QM. They just need to input the models. Of course, they should make the model first and then input into the software. With this, make the problems is more easier to solve. The students then present their own findings about the POM/QM or the solution to the problems, and some students show good confidence in explaining the solution even when hit by a series of questions. Those activity is very neat to improve understanding, critical and creative thinking, and to practice their confidence in front of people, which is needed as teacher in the future. Our conclusions, the chapter design in the study is available in our paper. The conclusion from our study is the chapter design is able to foster students' interest, contextual awareness, and their appreciation to the topics. The technology integration, the technology integrated properly without difficulty. The technology and the content filling each other in the chapter design. The chapter design itself is able to foster the mathematical disposition, but to foster mathematical disposition, of course, continuous treatment is needed until the disposition occurs frequently. Thank you for watching my presentation. I am Kandaga. You can contact me at my email. See you next time.